Hi everyone, this video is going to go through the study guide for the Unit 3 test happening next Wednesday. This is very similar to the test, so make sure you follow along, pay attention, definitely complete the study guide, watch this video like you're doing, and make sure you understand all the answers. Okay, the first question says we have a circle that has a mass of 4 grams and a square has a mass of 3 grams. What is the mass of the triangle? Okay, so this is a hanger diagram, which means we can model this as an equation. And we can label with numbers what we know. So circle 4, 4, 4, 3, 3, 3, 3, 4, 4. Okay, a key idea of solving equations is that if you have something on one side of the equal sign, on both sides of the equal sign, you can take it away from both sides. Or if you do something to one side of the equation, you have to do it to the other. So I can get rid of that circle, which is fine and allowed, as long as I also get rid of this circle, so it stays balanced. Same thing this circle, same thing this circle, same thing this square, same thing this square. Okay, when I'm left with that, I have 4 triangles on the left, 2 triangles on the right, a circle, and 2 squares. So I can continue to use this elimination method. I have a triangle on this side, let me get rid of that. A triangle on this side, let me get rid of that. I took away 2 triangles from the right, so as long as I take 2 triangles from the left, then we're all good and balanced. Okay, so that makes me left with, on the left, 2 triangles, and then on the right, 4, 7, and 10. So my 2 triangles have to be equal to 10 total. So I can divide that by 2, and 1 triangle has to equal 5. $5 grams, since they're giving us units of grams. Okay, so the key idea for that is if I have something on one side of the equation, something on the other, I can get rid of both. Okay, moving on to the next problem, we have Helena. Solve the equation below incorrectly, identify Helena's error, and then solve the equation correctly. Okay, so this is a case where we have parentheses. Remember, when we have parentheses, that means we need to distribute. So I'm going to distribute the number outside the parentheses to the 2 numbers inside parentheses by multiplying. I'll just do it over here. Rewrite it, since we're going to need to solve it correctly. Five goes to the 1/5 x, and 5 to the -5. So first I have 5 times 1/5 x. 5 times 1/5 is equal to 1. If you don't know this, this is an important kind of fraction concept to know. 1/5, 5 1/5, that's equal to 1. So this is going to give me 1x. And then I have minus 5 times 5, that is equal to 25. So this looks good so far. Then on the right hand side, I have -2 times 2x, that is indeed -4x, and then I should have -2 times +4. -2 times 4 is plus -8. Okay. But they have +4. So they did not distribute that -2 to the 4. So that's their mistake. There's only one mistake in this. We can continue to solve it, but the rest is correct. That was their one mistake. So identify the error. I need to show or explain it here. Helena forgot to distribute the -2 to the +4 in the second line. Right there, that is the issue. So I did it correctly, it should be +8, -8 instead, and then for there, just keep going. So now I want to solve it. I have variable terms on both sides, constants on both sides, so I'll choose something to get rid of. I'll choose to get rid of this -4x. So I'm going to rewrite this. 1x minus 25 equals -4x plus negative 8, leaving myself some space, and then I need to get rid of a negative 4x. Just like they did, you get rid of a negative 4x by adding 4x. So I add 4x to both sides. Over here, negative 4x plus 4x goes away to 0, and I just get negative 8. On the left, I have 1x plus 4x is 5x minus 25 equals negative 8. That was good because now I only have variable terms on the left, but I still have constant terms on both sides. I want to get this x by itself. Right now it is not by itself, it's being bothered by this plus 25. So I get rid of that by adding 25 to both sides. And then we have negative 8 plus 25 on the right. That is equal to positive 17. And finally, we're going to divide both sides by 5, since x is being multiplied by 5. And I get that x is equal to 3.4. Okay. And that's it. That is right. X equals 3.4. So we found Helena's mistake, we explained her mistake, and then we correctly answered the problem. So you got to do all three of those. There's a question just like that on the test, and I expect you to do all three of those things. All right, moving on to question number 3. Here we need to determine whether each equation has no solutions, one solution, or infinitely many solutions. Select the correct cell in each row and show your thinking. So let's start here. We have 16x minus 12 equals, now I have parentheses. Whenever I have a number multiplied by things in parentheses, that means I need to distribute, multiply. So I have 8 times 2x, that is 16x, minus 8 times 2, which is 16, and then plus 4. Okay, let me continue to simplify on the left. Nothing I can combine since those are not like terms. But on the right, I have just 16x I'm going to bring down, and then I have minus 16 plus 4. Remember, I need to think of this minus 16 as like plus a negative 16. So that's like negative 16 plus 4. Negative 16 plus 4 is negative 12, which I could also think of as minus 12. Okay, either way here, I have 16x and a minus or a negative 12, so I get the identical things on both sides of the equal sign. Same variable terms and the same constant terms. I could continue to solve this, and I would get some truer equation like negative 12 equals negative 12, 0 equals 0, 16x equals 16x. All of those are telling me I have infinitely many solutions because I have identical things on both sides of the equal sign. Awesome. All right, let's keep going. Now here I have negative 7x equals negative 7x plus 5. I can immediately conclude that this is no solutions because we have the same variable terms on both sides. But we have a plus 5 on the right and nothing, no plus 0, on the no constant terms on the left. However, it might be good to show a little work, make us understand that a little better. So if I were to try to solve this, I would try to get rid of this variable term, the negative 7x, on one side of my equation. So if I do that, I add 7x to both sides. Then on the left, I'll have negative 7x plus 7x, which is 0. And on the right, I'll have negative 7x plus 7x, also 0, plus 5. And I'll get a false statement, like 0 equals 5. So I know then I have no solutions. And finally, this last one, again, I have parentheses, so I distribute. 2 times 3x is 6x. 2 times 1 is 2, so I get 6x minus 2. And then here I have 6 times x is 6x minus 6 times 1/3. 6 times 1/3 is equal to 2. So this is also 6x minus 2. Again, I have identical things on both sides of the equal sign, so I have infinitely many solutions as well. Note here, none of these had one solution. I'm not saying on the test that it will necessarily look just like this or anything, but just because there's 3 options and there's 3 problems doesn't mean that necessarily all the options are going to be chosen. Okay, so these two were both infinitely, and this one was the no solutions. All right, moving on to 6. Now we're really getting into the systems problems. This was kind of our before break work. And now this is our after break work doing systems. We're told a line is graphed on the coordinate plane below. Graph the line y equals negative x plus 6 on the same coordinate plane to create a system of equations. What is the solution to that system? So some line is already graphed here. They don't tell us what the equation is. We could figure it out if we wanted to. This is not necessary, but this has a slope of 1/2 and a y-intercept of 3. So we have that one line. And then we need to graph this second line, y equals negative x plus 6, and see where the two lines intersect to find the solution. Remember, in slope-intercept form, B, that's the y-intercept, where the line crosses the y-axis, and M is the slope, the vertical divided by the horizontal. So in this case, y equals negative x plus 6, the y-intercept is 6, so I'm going to start here on the y-axis at 6 at the point 0, 6. And then my slope is a little trickier. The slope just looks like a negative sign. But we know when we don't have a number, a coefficient in front of the x, we could just make it 1. So this is really a slope of negative 1. Whenever we graph using a slope, we want to interpret that as a fraction. Negative 1 is equal to negative 1 divided by 1. And slope is ultimately equal to the vertical change divided by the horizontal change between any 2 points on a line. A vertical change of negative 1 means I go down 1. A horizontal change of positive 1 means I go right 1. So from this point up here, down 1, right 1, down 1, right 1, down 1, right 1. This is my line. And where do those two lines intersect? Of course, they intersect at this point, which is 2, 4. So that is the solution to the system of equations. Okay, so you have to actually graph that line. So that's going to be an important skill on this test, is that you're able to graph a line in slope-intercept form for the equation, from the equation to the graph. All right, and that takes us to number 5. So 5, we have Jordan and Bryce are going to work for their neighbor this summer. The neighbor gives Jordan $10 at the beginning of the summer and then pays them $8 each week to mow the lawn. The neighbor pays Bryce each week $9 each week to walk the dog. The graph shows the model below models the total amount of money Y each person has earned after working X weeks. Circle the option below to represent the point of intersection on the graph. Okay, so I'm going to do a little bit more than I need to here, but this first top equation, top line, this is Jordan. I can tell that because Jordan has an initial value, a y-intercept of $10, and then a slope of $8, so it's going up by 8 each week. Below here we have Bryce's graph Rice's linear equation is just y equals 9x. It doesn't start with any money, and then he gets $9 each week, which we can see. Okay, we can see that Bryce and Jordan's lines intersect at this point right here. This is the point 1090. So we're being asked to interpret that point on the graph. Okay, so first we have after 10 weeks, Noah has earned a total of $90 and Aiden has earned a total of $10. So after 10 weeks, weeks is my x-axis, so this point is really 10 weeks, comma, and then on my y, I have $90 total amount earned. After 10 weeks, both Jordan's graph, Jordan's line, and Bryce's line are at this point. So at 10 weeks, Noah does have the $90, but Aiden also has $90, so not $10, they both have $90, so not A. B, after 90 weeks, okay, let's just stop there for a second. Weeks worked, right, we're only going between 0 and 12 weeks worth. This 90 refers to $90, that's the y-axis, not the weeks, so off the bat, that is wrong. C, after 10 weeks, each person has earned a total of $90. That is this point where they intersect. 10 weeks, $90, they both hit it. And again, it's not 90 weeks, it's $90, not $10, but 10 weeks. So all you have to do is interpret that point of intersection. Cool. All right, moving down to 6, which system of equations has no solutions? Show or explain your work. So we have 4 systems of equations. They're all set up nicely for us to use the elimination method, like we did last week, because we see the like variable terms and constants are on top of each other. X's, Y's, constants, X's, Y's, constants, they're all aligned. Okay, so in order to figure out which one has no solution, you might be able to look at it and get it more quickly, but I'll just go through all of them to get a sense of how many solutions they're going to have. So to figure out all the work we do with elimination, we look at the coefficients to the variables and we see what's going on. So what are the x's and the y's being multiplied by? Looking at A here, I see 10 and 20 and 4 and 8. Those are not the same coefficients. They're not opposite coefficients. They're neither. So we can't just add or subtract. In order to solve this system, we're going to need to multiply first. Okay, so let me rewrite that. And then see what I can do to multiply. So let's say that I want to make this 10x 20x, because then I would be able to subtract to get rid of the x term. In order to make this 10x 20x, I'm going to multiply my top equation by 2. Remember, we have to multiply the entire equation by that in order to keep it balanced and true. So I multiply the entire equation by 2. Then I bring the other one, 20x plus 8y equals 10. And looking at that, I should observe these are in fact actually the same line. 20x plus 8y equals 10 and 20x plus 8y equals 10. If I didn't notice that right away, I could again see that the x's, they have the same coefficient, so I could go ahead and subtract. 20x minus 20x is 0. 8y minus 8y is 0, and 10 minus 10 is 0, so I get 0 equals 0, which is true, always. Doesn't matter what x is, 0 is equal to 0. So A is going to have infinite solutions. Okay, that is more than I needed to write down, but that is not going to be our answer because A has infinite solutions. Moving on to B. Looking at that right away, I see that my x coefficients 3 and 6 are neither opposites nor the same. But when I look at my coefficients for y, I have a minus or a negative 2y, and then a plus or a positive 2y. So these are opposite coefficients. I can try to solve by adding them together. And when I do that, 3x plus 9x, or 3x plus 6x is 9x. Negative 2y plus 2y is 0, and 9 plus 9 is 18. So I get 9x equals 18. Divide both sides by 9, and I get x equals 2. I could then go and figure out what the y-coordinate is that corresponds with that if I was asked to actually solve the system, but that's not what they asked. They just said which system has no solutions. I can tell, since I get one x value here, that this is going to have one solution, not no solutions. So B is not going to be our answer. Okay, moving on to C. 2x minus y equals negative 11, and negative 2x plus y equals positive 11. Okay, looking at this system, I immediately see that my x coefficients, 2 and negative 2, are opposites. So I could try to solve this by adding these together. And when I do that, 2x plus negative 2x is 0. Negative y plus y is 0. And negative 11 plus 11 is 0. So again, I get 0 equals 0, which is true always. So we have infinite solutions. So that's good in a special case, but it's not no solutions, so it's not C. That takes us to D. It must be D, and it in fact is. 4x plus 6y equals 1. 4x plus 6y equals 9. Just looking at this, I see I have 4x plus 6y on both left sides of the equation. But in one circumstance, that's equal to 1, and in another, it's equal to 9. It's impossible for the same thing to be equal to two different numbers. So this is going to mean we have no solutions. But I'll go ahead and try to solve it like I would. 4 and 4 are the same, so I'll subtract. 4x minus 4x is 0. 6y minus 6y is 0. And 1 minus 9 is negative 8. So we get 0 equals negative 8. That is false. 0 does not equal negative 8, so that means there are no solutions. It is impossible to find an x and y value that makes both 4x plus 6y equal 1 and 4x plus 6y equal 9 at the same time, because they can't have two different sums if we have the same x and y. So on the test, just for the record, you wouldn't need to have all of this work necessarily, but you should have work for D at minimum, explaining why this one does have no solutions. Cool. All right, and our final question, question 7 on the back. We have Hector and Michelle are each saving money. Hector starts with $50 in his savings account and adds $10 per week. Michelle starts with $20 in her savings account and adds $20 each week. First, we're asked to write a system of linear equations that represents this situation. You'll see I originally had Andre and Elena there. I crossed that out. That's just a typo from my end, because on the real test, which is how I made the study guide, Andre and Elena are the real names. So Hector and Michelle are the study guide names. Alright, so Hector starts with $50 in his savings account and adds $10 per week. Okay, so I'm going to go ahead and I'm going to say X is going to represent my number of weeks, and then Y is going to represent total money in savings. For Hector, his total money in his savings account is equal to the $10 he makes per week, $10 X, plus the $50 that he starts with in his savings account. That's his initial value, his starting value. And then Michelle makes $20 each week and starts with $20 in her savings account. So that's going to be 20x, $20 per week, plus 20 for the $20 in her savings account. This is now my system of linear equations that represents the scenario. We can use those two equations to figure out after 2 weeks who has more money. So here's Hector. Here's Michelle. And I'm trying to figure out after 2 weeks. That means X, my number of weeks, is equal to 2. So after 2 weeks, Hector has $10 times 2 for the 2 weeks that he's worked, plus the $50 he started with in his account. That's Y equals 20 plus 50. Hector has $70 in his savings account after 2 weeks. Whereas Michelle, again, X is 2 for 2 weeks, so I substitute in 2 for X. You get 20 times 2, which is 40, plus 20 that she started with, and Michelle has $60 in her account. So Hector has $10 more. Than Michelle after 2 weeks. We can see that from the work I have above. Okay, and finally we're asked, after how many weeks will Hector and Michelle have the same amount of money in their savings account? Solve the system of linear equations you wrote in part A to get your answer. So I have my system. I'll just rewrite it here. And I need to try to solve this to figure out who has more money. Okay, to solve this personally, I would solve this using the substitution method, where we see that we know Hector's money, H, needs to be equal to Michelle's money. Hector's money, Y, Hector's Y, needs to be equal to Michelle's Y. Hector's money has to be equal to Michelle's money. So I need Y to equal Y. For Hector's Y, I know that's equal to 10x plus 50. And Michelle's Y is 20x plus 20. So then I'm going to solve this system of equations. Just solve this resulting equation to figure out X after how many weeks they'll have the same amount of money. Okay. So at this point, I have X's on both sides, constants on both sides. I need to get rid of something to move all the X's to one side and all the constants on the other. I would solve this by rewriting the equation as it is, and then getting rid of something. So personally, I would probably get rid of the 10x first. We get rid of that positive 10x by subtracting 10x from both sides. And when you do that, you have 10x minus 10x. That goes away to 0, and we just bring down the 50. On this side, we have 20x minus 10x is 10x, and then plus 20 that we bring down. Then we need to solve for x. My 10x is currently being bothered by this plus 20, so I'm going to get rid of it by subtracting 20 on both sides. And I get 30 is equal to 10x. And finally, x is being multiplied by 10. I'm going to undo that multiplication by dividing both sides by 10, and I get x equals 3. So this says that Hector and Michelle will have the same amount of money in their bank accounts after 3 weeks. We could go and figure out how much money they have, and I'm going to do that for good measure, but technically it's not what the question is asking. So in order to do that, to finish solving the system, I'm going to rewrite one of my original equations. Substitute in 3 for x, and I will get y equals 80. You can check that in the other equation as well. 20 times 3 is 60, plus 20 is 80. And since this is a word problem, remember I have to answer the question asked. Hector and Michelle will have $80 each in their accounts after 3 weeks. And as a note, this test is about solving systems of equations, so it's possible you could have figured that out by sort of like a guess and check method, which wouldn't give you no credit, but it does. This problem is requiring that you solve the system of linear equations. So I see this sort of work and step. All right, that's everything. It's just like this. So if you understand this, you should be good on the test. Be sure to ask for help if you need anything, and good luck on Wednesday.